Good morning. Hey, everybody. Welcome to the last day of Devoxx. Thanks for coming in this morning. My name is Stuart Marks. I work on the JDK core library team at Oracle, and among the various tasks I do is I work on the collections framework. So this title of the talk is Collections Refueled. I'm going to talk mostly about the new enhancements we've made in JDK 9 with a little bit of stuff for the future. I have selected a hashtag, #collectionsrefueled, for Twitter. So if you tweet with that hashtag, I will look at the I will look for those tweets afterwards and try to follow up if people have questions. We'll see if we have time at the end for questions as well. Okay, so one slide on the history of collections in Java. So JDK 1.0 was introduced in 1996, and the collections, they weren't called that, but what we now call the legacy collections, which consisted of mainly vector and hash table, or hashtable as we call it, since the capitalization is wrong. So those were what we call the legacy collections introduced in 1.0. And so those served for a little while, but it wasn't until JDK 1.2 was introduced a couple years later that what we now call the collections framework was added. And so that is where the implementations and interfaces that we're all familiar with, such as collection, list, set, map, array list, and hash map, and so forth. That's all that stuff was introduced in 1.2. Now we've done a lot of enhancements to those over the years, but basically it's interesting that those interfaces and those implementations have been around for that time, almost 20 years at this point. So those were very useful, of course, and a big update to those occurred in Java SE 5 in 2004 when generics were added. And so at that point, up until that point, everything was raw types, and so you had to be careful about making sure about the types of what you put into collections, and you had to do casting on the way out. And so generics made it possible for you to have a type-safe collection, which was not really the case before. Also in Java 5, the Java util concurrent package was introduced. So I'm not really going to talk about that very much, but that's an interesting kind of adjoint to the collections framework, basically a set of highly scalable concurrent collections. And in Java 8, although we didn't actually do that much work on the collections themselves, we added Lambda and streams. And so streams is not formally part of the collections framework, but it works very, very well with the collections framework. So every collection can be streamed, and you have all those nice stream operations, and then at the tail end of the stream, you can collect back into a collection. So that was a big enhancement that worked very well with collections. But also in Java 8, there was a whole family of default methods that were added to the existing collections interfaces. And so what that did was it had the effect of enhancing every single collection implementation, even ones that did not change as part of Java 8. And of course, what we did is we optimized and enhanced the built-in collections. But even if you had a collection that was not built in, even if you didn't update it for Java 8, you would get the benefit of all of the new default methods that were added. All right, so that's all I'm going to talk about with history. I think the theme of this talk is, all right, Java 8 was a big deal. Java 9, we are continuing to move forward with the collections framework. So what we did was a project called the Convenience Factory Methods for Collections. The main goals were convenience and brevity, space efficiency, and unmodifiability. A quick word on that: in previous talks and in the Java 9 documentation, it talks about immutability, which I think is a little bit confusing. So I'm going to switch over to using the term unmodifiable, or unmodifiability henceforth. All right, so what are these things? All right, so we have a set of library API changes. We are not changing the programming language at all for Java 9, at least regarding collections. There have been discussion and proposals in the past to add collection literals to the language. And we did some development on those, and there were a few prototypes. And it turns out that is actually a much harder problem than it looks. There's probably a very much longer explanation than I have time for here about that, but we did do a serious investigation of it. And the way I'd put it is the basic problem with enhancing the language to support collection literals is that what it does is it binds the collection libraries too closely to the programming language. And so if you look at the way things are, there are no dependencies today in the programming language that talk about Java util list, Java util collections, and so forth. And so if we added collection literals to the programming language, the first question is, okay, what is the type of the thing? Is it a Java util list? Okay, what class is it? Is it an array list or is it something else? So if you have a collection literal, now you're starting to bind these class libraries directly into the programming language. And that was very, very uncomfortable because we might want to change those in the future. So, and there are a bunch of reasons why that became much more complex to add collection literals than it might first appear. So instead what we did is we said, okay, we want to have the ability to specify a collection kind of in a collection literal-like syntax, but instead of changing the programming language to do it, we decided to add library-only APIs to do it. And we believe we have achieved about 80% of the benefit of what we could have gotten using collection literals at far less complexity than adding collection literals to the programming language, maybe an order of magnitude less complexity. All right, so this is basically the API here. I'll leave this up for a little while so you can digest it. The idea is that if you want to have a certain number of elements and put them in a list, you say list.of, and it's basically just a varargs method. So you can just say list.of however many elements you want, including 0 or up to an arbitrary number. If you want to have a set of elements, you can specify varargs list of varargs parameters for the members of that set. Map is a little bit different. You can say map.of, but then you have to specify keys and values, which in general can be of different types. So we can't do a straight varargs there. So instead what we did was we had a set of fixed argument overloads for map.of, where they alternate the key type and the value type. And we have that going up to 10 map entries. But if you want more than that, there is a different method called map.ofEntries that takes map entry instances. And so that's a little more cumbersome. We made that a little easier because we've also added a static method called entry. You can see that lowercase entry that takes a key and a value pair, takes a key value pair and returns an instance of map.entry. So if you want to add more than 10 elements, if you want to add more than 10 mappings to one of these maps, you can say map.ofEntries. So this is what the Java doc looks like. So it looks pretty ugly in the Java doc because they're basically all these redundant overloads that differ only in the number of arguments. But the good news is that you don't see this when you're actually using the APIs. Sure, you pop up autocomplete when you in your IDE and you see a bunch of overloads, or you see this in the documentation. But when you're programming, you just say map.of or list.of or whatever, and then you just type the number of arguments you want. And the only time you need to worry about it is if you have more than 10 key value pairs for a map. You have to switch over to map.ofEntries. But otherwise, this basically just works, and the compiler finds the right overload for you, and you just move on. All right, so let's show these things in action. Suppose you wanted to have a string list that was unmodifiable. So in the past, what you'd have to do, I'll read this kind of from the inside out. So you'd say arrays.asList to get a sequence of elements there, and then wrap that in collections.unmodifiableList, and then assign that to your variable. And so in Java 9, all you have to do is say list of A, B, C. And that's pretty easy, pretty straightforward. Okay, set example is almost the same, but it actually gets a little bit better because it's harder. Prior to Java 9, it was harder to initialize a set. And so what you had to do is arrays.asList was quite convenient because, well, it still is actually, but it's a varargs method, and so that's a nice way to list off an arbitrary sequence of elements. But then what you had to do is copy that into a hash set, and then what you had to do after that is wrap an unmodifiable wrapper around it. And so now in Java 9, you simply say set of ABC. It becomes much simpler. All right, so quick example with map. So here, basically, there's really no good convenient form of doing this prior to Java 9. You had to create a hash map and then just call put a number of times, and then wrap the result in an unmodifiable wrapper. Sometimes you will find people advocating the double brace idiom to initialize a map. Please don't do that. It's beyond the scope of this talk, but there's some very good material out there that tells you why you shouldn't use the double brace idiom. Anyway, but you don't need to do that anyway in Java 9 because you simply say map.of a, 1, b, 2, c, 3. All right, so, and notice what's going on here is when you declare the variable on the left-hand side, you can say map.of, and you just give the values, and type inference makes sure that it type checks all of the arguments. And so if you accidentally put a string in the wrong position, then you'll get a compiler error. So this form is type safe. And also, you might have also heard that in the next release, we are working on something called local variable type inference, or var. And so this actually type inference works here as well. I don't have an example, but you can say var string map equals map.of a, 1, b, 2, and so forth, and it gets the right type. So it's very convenient to use that with new features in upcoming releases. All right, now here is an example of using a map with more than 10 entries. And so in this case, you have to fail over to using the map.of entries method instead of map.of. And here you have to have a succession of calls to the entry method. And so here we're just, so if you're writing a parser or something, you might have a mapping from string to token type or something like that. And so here we just have a succession of entries with some kind of string and some enumeration constant or something like that. And so that's what that looks like. So that gets kind of verbose, but it's still nicer, I think, than initializing hash map this way. All right, so moving on from the API, I wanted to spend a fair amount of time on the implementation characteristics of what you get back. So we have these new APIs, list.of, set.of, map.of, and they don't return kind of the obvious collections. So list.of does not give you an array list. Set.of, map.of do not give you hash set and hash map. They give you new internal private implementations. Private in the sense that the class name is not visible to you. There are no constructors here. The only way to get instances of these new implementations is via list, set, and map.of. So these implementations have a bunch of different characteristics that differ from what I'll call the conventional collections. The first one is that they are unmodifiable. And so if you, well, actually I have details on this later on. But anyway, there are a bunch of things where these characteristics differ from the conventional collections. They're unmodifiable, they disallow nulls, randomized iteration order. So I'm going to spend some time on that. That's something that's caused a bit of controversy. They disallow duplicates, and there's some things in there. They actually throw an exception if they detect that they're duplicates being initialized with duplicates. So one thing that's very attractive is also that they're much more space efficient, at least for hash set and hash map, much more space efficient than their modifiable counterparts. And they are serializable, and there's some details to talk about there as well. All right, so let me talk about unmodifiability. So as I mentioned before, I'm not really using the term immutable anymore, and the reason is that these are just collections, and if you take a mutable object and add them into one of these, what you get is still mutable. So calling these immutable collections is potentially misleading. In fact, I've had questions from people who say, oh, well, so if I take a mutable object, if I take a mutable object and add it to one of these collections, does the whole thing become immutable? No, there's no magic here. The collection itself is unmodifiable. But if you put a mutable object inside of one of these collections, then the whole thing actually is still mutable. So there's a more precise definition of what it means to be unmodifiable, which is that there's a family of methods, add, set, and remove, and there are a handful more. But basically, those are the things that modify the elements of the elements contained in the collection. Those will all throw unsupported operation exception. So what good is this? It's kind of surprising. I guess I've been so close to this. It's like, of course you want your collections to be unmodifiable. And I've had some questions like, well, what good is an unmodifiable collection? Don't you want to add more stuff to it? And so not necessarily. I mean, obviously we still have the conventional collections. You can add and remove elements. They're still very useful for those purposes. But there are lots and lots of use cases where you want to create a collection, you know what elements need to go into it at initialization time, and you want to put them in, and you never want to change that collection later on. And so that's what these are useful for. So there are actually a lot of cases where that occurs. And in fact, these were added some time ago in the JDK 9 release cycle, and we've started to use these APIs in JDK 9 itself, and people are really happy with them. I think it certainly helps space utilization and startup time to use these in JDK 9 itself. So there are a lot of places in the JDK, and probably also in other libraries and application code, where you want to initialize things and then never change it afterwards. So another case is if you have a data structure and you have a getter for something, you can hand out a reference to one of these, and you can be fairly well assured that your caller cannot accidentally modify the contents of your collection. So that's pretty nice. You don't have to make defensive copies anymore. You can just hand it out. So you've probably heard that immutability in data structures really helps thread safety, and it certainly does. So if you have immutable objects inside an unmodifiable collection, then right there you've taken a big step towards making your data structure thread safe. I also mentioned space efficiency already. So I think one thing to draw a distinction here is that these new collections implementations contain elements themselves. And this is in contrast to the existing things like collections.unmodifiableList, which are wrappers around another collection. So these contain the elements themselves, whereas the wrappers are simply a view onto some other collection, which actually might be modifiable. So here I have a quick example of that. So I have a list of integer that is created using arrays.asList, and I wrap that in collections.unmodifiableList, and I get that and store that in list 1. And then in list 2, I say list.of 1, 2, 3. So those lists have the same contents. So they're both similar and different. They're similar in that if you call add, remove, or set on list 1 and list 2, those will all throw unsupported operation exception because they're both unmodifiable. But list 1 is an unmodifiable view of the list named inner. So you can go in and change that, and that change will be visible in list 1. So that's what we mean by an unmodifiable view. Whereas list 2 cannot be modified at all. So not only can you not change the contents with add or remove, but since the members are integers, which are immutable, the whole thing is immutable. But again, you have to be a little careful. If you want the whole thing to be immutable, don't put mutable data into one of these lists. Okay, moving on. So all of these collections disallow nulls. So you can't have nulls in list or set, and you can't have null keys or values in the map. And so there's no way for us to check this at compile time, but the best we can do is when you try to create one of these lists, if you happen to pass a null in, then it'll throw a null pointer exception. And so this is, I mean, there are a couple of reasons for this. I think it's widely regarded that when the collections framework was introduced back in 1.2, the allowance of nulls in certain collections, particularly hash map. I think hash map is the only map it's the most popular map implementation, and it's the one that allows nulls. Most of the other map implementations, I don't know about all, but most do not allow nulls. In particular, concurrent hash map does not allow nulls. And so if you look at hash map, it turns out there are a bunch of special cases laced throughout the code where it says, oh, okay, let's take the key. Oh, if it's null, then do the substitution. And it has to do the substitution all over the place. And so that's extra work. But it also means that well, basically the biggest problem is with map.get and also other APIs like map.compute. So if you say map.get and you pass it a key, you get back the value that corresponds to that key. What if that key is not present in the map? Well, map.get returns null. What if the key is present and the value is null? You also get back null. So you can't tell if your map values, if one of your mapped values is null, map.get basically doesn't work. You just can't use it without worrying about whether the key was absent or whether it was present and null. So there's some semantic issues like that with including nulls in maps. But there are also some implementation issues. Some implementation advantages you can gain by disallowing nulls as part of the data. Just the internal organization uses nulls as a special sentinel, and so the internal implementations take a lot of advantage to that to make things smaller and go faster. So anyway, this is not a new precedent. I think any collection that was introduced since 1.4 or 5 has disallowed nulls. So for the most part, we're just continuing along with that. All right, so this is something that has caused some confusion and consternation. There's a long history about the iteration order of various collections that are hash-based. So if you look at the specifications for particular things like hash set and hash map, if you look at the method, the iterator method says something like returns the elements in this set in no particular order. But there's this problem, which is that it turns out that the hash code for most data is very stable. The hash code for string, which is a very common thing to put in sets or uses map keys, the hash code for string is actually pretty poor and doesn't really randomize things very effectively, or doesn't really spread values around very effectively, which is what you want from a hash code. And so it turns out if you put a bunch of strings into a hash set, they'll come out in alphabetical order if they're the same length. So the typical thing is you say, add A, B, and C to a hash set. It turns out if you iterate over the hash set, they come out in order. And that is very misleading. And what happens is, in practice, code gets written that makes assumptions about the iteration order of hash set and hash map. And occasionally, we have reasons to change the internal structure of something like hash map, either for optimization or to improve the security of the system or things like that. And that changes the iteration order. And what happens is that a bunch of code breaks. And then we have this argument, which is, hey, you guys broke our code. And we say, well, oh yeah, I guess we changed the iteration order. But look, the specification says you mustn't, it doesn't return the elements in any particular order. But my code was working for years and you broke it, right? And so unfortunately, it's like everybody likes to say, I'm right and you're wrong. But the fact is, when you're in this situation, it's very uncomfortable, especially when the guy saying you broke my code is a very, very, very large customer. So those kind of conversations are very difficult. And so what we do is we say, OK, we promise we're never going to change the iteration order of hash map again until the next release. And then what happens is, since the iteration order of hash map doesn't change very often, there's a whole crop of new code that gets written that makes dependencies on hash map iteration order, and then it gets broken again. And so there's a real problem here where the specification says there's no particular order defined. And in the implementation, there are always opportunities to make changes to optimize and improve things, but that changes the iteration order. But we hold back from doing those because we don't want to change the iteration order and break people's code. All right, so that's the history. So these are brand new collection implementations in Java 9. So nobody, by definition, nobody can have any order dependencies on them. And so what we've done is for the new set and map implementations, we actually randomize the iteration order of set elements and map keys. And so when the JVM starts, it basically takes a random number and then just XORs it into the hash code. And so in practice, what will happen is every time you run every time you run an application, you'll get a different random number, and for the new collections from set.of and map.of, they will be iterated in a different order. And so what we're doing is we're saying, okay, we're standing behind this idea of we're not returning the elements in any particular order, and instead of changing it as infrequently as possible, we're changing it very frequently. Every time a new VM starts, you're going to get a different order. And what that should do is have an effect of preventing code from being written that has implicit dependencies on iteration order. So now I want to stress that the existing implementations like HashMap are not changing. So we're not going to cross that bridge, at least not yet, although there are some things we might do. So HashMap is not changing. So its iteration order is, although it's not guaranteed to be stable, we are not randomizing its iteration order. Whereas for the new set and map implementations, we are randomizing them. So one of the things I've said in the past, and I've stopped saying, and it's also one of the things I've heard, is, well, people should just learn to write code that doesn't have iteration order dependencies. And to a certain extent that's true, but in large systems it's been our experience that these iteration order dependencies can and do creep in regardless of how careful you are. So we're hoping that this new feature will flush those out early during testing and development and prevent problems from occurring, and mainly we want to be able to have the ability to improve, optimize, and maintain these new collection implementations at will, and therefore be able to change the iteration order at will. And so if the iteration order is randomized, then making an internal implementation change that changes the iteration order should really have no effect whatsoever. So this is part about protecting our ability to evolve the system, but it's also about the ability of preventing these kind of bugs from creeping into application code, for which it's actually quite difficult to test. All right. So it's interesting. So this is new for Java. This is kind of a new thing because most things in Java have very, very predictable, very, very deterministic behavior. But in looking at other systems, in particular Go and Python, they have also used randomized iteration orders. So this has been in Go from the very beginning. And it's interesting because people do complain about it, and if they want to preserve iteration order, they have to do more work to do that. Python has gone back and forth on this. Python 2, I think, it's a similar thing. The specification, or at least if you ask Guido, the maintainer of Python, he'll say that there's no specification over the iteration order of the equivalent of map in Python. And so in Python 3, they actually randomized it. But I think at least starting in Python 3.6, there's actually a new implementation that was put into Python that does have predictable iteration order. It's predictable in that it won't change, but it's still not specified to have that order. So that's a discussion that's still going on in the Python community, because there's a group of people who want to have predictable and specified iteration order. So I think Python is moved back into an uncomfortable position where it is in fact stable, but it's not specified. So theoretically, they're reserving the right to change iteration order again, but you can see they'll run into potentially exactly the same problem if code has been developed that starts to depend on this new iteration order. So anyway, if you are concerned about this, about iteration order, then don't use these new map implementations. That's one approach. You could stick with hash map if you're using that, but there are other implementations in the JDK, in particular linked hash map and linked hash set, that preserve insertion order as iteration order. So if you insert things in a particular order and then iterate, you will get a predictable order that's the same as the insertion order. There's also an access order variation of those. So if you want to preserve, if you're concerned about iteration order, even if you're using hash map, you should probably convert to linked hash map, because there's a possibility that we might change the iteration order of hash map again in the future. All right. Okay, so duplicates are disallowed. So this is for set elements and map keys. And so, of course, by their nature, you can't have duplicate elements in a set. But what's different here is that since you know all the elements at construction time, it is probably an error if you're writing out a list of elements and you have duplicates in them. And so we consider that to be a programming error. Remember, I started talking about collection literals. So this is modeled on collection literals. So if you want to create a set using a particular set of, if you have specific elements you want to add to the set, if you have duplicates in that, then it's a little strange, and you might have made an error. So what we do is we throw an exception when we discover that at initialization time. This is something that's a bit unusual. There aren't many systems that do this. Most other systems, what they do is they have like a last one wins policy. And I think that's a little bit dangerous, right? So if you take a look at this example, so this is a modified version of an example I showed before, where you're adding a bunch of map entries to a map. And it turns out that there's a bug in this one. And if you might be able to spot it if you have sharp eyes, but there's a duplicate key in here. So if we followed a last one wins policy, then what would happen is silently you would get a map with one fewer entry in it than you expected, and you might have one of these tokens mapped to the wrong token type. And you can imagine a late night debugging session where it's like, you're looking at the stuff, oh, this looks right to me, how come I'm getting the wrong result, right? So I think this is common enough that it's worth error checking this. And so if we're running through the list of map entries and we encounter duplicate keys, we'll throw an exception at this point. All right, so here's an implementation concern about space efficiency. So one of the reasons that we are, if you look at most of the existing collections, are public classes with public constructors. So if you want a new array list, you say new array list, and you can add elements to it and so forth. The classes that implement these new collections are not public, and so they're all protected behind static factory methods. And so one of the reasons we do that is that we choose different implementations for the collections based on the collection size. So in particular, for list and set, if you have 0, 1, or 2 elements, we use specialized, extremely compact implementations that store only 0, 1, and 2 elements. They don't even store them in an array. And then for map, if we have 0 or 1 mapping, those are also stored in fields. So that gets a very compact representation for those. Now, if you have list, set, or map with a larger number of elements or mappings, then we do use internal arrays, but we have a different array organization. So instead, but anyway, so the benefit is overall there's less space consumed by these, and they're not necessarily faster, but they're not as slow as you might expect because the locality of reference is improved compared to hash map. All right, so let me run through a quick example of space efficiency concerns here. So let's say let's create a hash set in the conventional way and create a hash set and add 2 strings to it, foo and bar, and then wrap that in an unmodifiable set. So if you count the well, you have to know a little bit about the actually, I have to know a lot about the internal implementation of hash set. So a hash set is actually built on top of a hash map. So a hash set is simply a hash map that where the set elements are keys in the hash map, and the value is some sentinel object that's irrelevant. So and a hash map, it has an internal array called a table, and those are hash buckets, and then the contents are a linked list of nodes that are hanging off of the hash buckets. All right, so if you count up the number of objects used by the collection, I'm not counting the strings themselves. I'm not counting the payload that's contained in the collection. Just talking about the overhead of the collection itself. An unmodifiable set constructed this way takes a lot of objects, right? So we have the unmodifiable wrapper. We have the hash set object. The hash set contains a hash map. There is an array, which is another object, which is the table. And then there are two node objects, because every mapping has to have a node object. And then that contains the pointer to the string itself. So we have 6 objects. 1, 2, 3. Yeah, 6 objects. All right. So this is a diagram of what it looks like. So you have each box is an object, and then each node contains references to the key and the value. All right, so now let's talk about the size of these. And so one of the things about Java is that small objects are actually fairly wasteful. So on a small heap size, there is a 12-byte object header for every object. And then if you have a large heap, then the header rises to 16 bytes. So I'm not going to go through all the details here, but if you add it all up, it turns out that storing 2 strings in an unmodifiable hash set takes 152 bytes. And that's not counting the strings. In fact, the strings themselves the strings themselves are not as small as you might think they are, but that's 152 bytes for just a 2-element set. So that's hash set. So if you look at the new set implementations, if you say set.of foo, bar, you can do a similar analysis. So here, this uses the field-based implementations. So a 2-element set just has 2 fields. And so that only takes 1 object, and those are references to the set element. And if you add that up, then the space consumed by a new set created using set.of takes only 20 bytes as compared to 152 bytes for a hash set. Actually, so another point here is that there are, if you look at the size of memory consumed by collections, there are really 2 things you need to look at, which is the fixed cost, which is the cost of creating a collection, even an empty one to begin with, and then there's sort of the variable cost, which is how much more space that a collection will consume as overhead as more elements are added, or as you create larger ones. And so the new collection implementations are much more space efficient. So they're smaller even for small sizes, and even if you add lots of elements, they have a lower per element size. So it's like, wow, this is really great. Well, remember, the reason we can do this is these are unmodifiable. So once you've initialized a set or map with these, with the elements, you can't change it. And so that's the benefit of hash map, of course, is that it has this data structure which is fairly large. The nodes, the linked list of nodes from the bucket. But the advantage is that updates to a hash map are very, very fast. So if you need updates, hash map and concurrent hash map are still the way to go, but you're paying a space penalty for that. If you don't need to modify it, then convert over to the new set and map implementations, and you can save a lot of space. Okay, so I said earlier that since there are no public constructors and no public classes, we will return. You call the static factory methods, and we'll return instances of some internal implementation of our choice. What happens if you want to serialize one of these guys? So what we do is if we didn't do anything else, then you serialized one, then the name of the internal implementation class would appear in the serialized output stream. And so we didn't want to do that because we want to preserve the ability to change the internal implementations at will. And so what we do is we use the serialization proxy mechanism. That's something that's described in Josh Bloch's book, Effective Java. There's an item that talks about serialization proxy. It's basically a pattern. But basically, all of the new set and map implementations use a single serialization proxy. And so that is the on-the-wire format that we are committing to. So if you serialize one of these collections in Java 9, and then we completely reorganize the implementations in Java 10 or 11 or something, we will commit to being serialization compatible going forward. Now, these are not serialization compatible with the existing collection implementations like hash map or array list. And so if you do need to have serialization interoperability with older versions of Java, then you must continue to use the existing collections. And if you think about it, that makes sense. We're introducing new implementations in Java 9, and you can't deserialize them on Java 8 since those implementations simply don't exist. All right, so that's pretty much what's going on in Java 9. So let's turn to the future and talk about what's going to go on in Java 10 or 18.3, or I guess we're now back to Java 10 here. We keep changing the versioning scheme. So this is a proposal that is currently out for review. If you look at the static factory methods, you can provide an explicit list of elements, or you can provide a varargs list, which actually is the same as an array. And it's actually kind of cumbersome. Sometimes what you want to do is compute or load or something, a collection of things, and then once you've computed that, then load them into one of these unmodifiable lists. And so what we're doing is essentially, what we're doing is proposing to add like copy factory methods. So list, set, and map dot copy of. And what those do is those take list and set take a collection, and map takes a map. And conceptually, what they do is they make a copy of whatever was passed in and use that to initialize a new instance of this collection, one of these collection implementations. In addition, we are also proposing to add some new collectors to the Streams API. So you might not want to pre-compute a collection. You might want to have a stream that computes some number of elements, and you might want to collect them into a list or set or map or something like that. But what the existing collectors do is essentially return in fact, what they do is they return an array list, a hash set, or a hash map. But what you might want to do is take the output of stream and send the results into one of these new unmodifiable unmodifiable collection implementations. So we're proposing to add a set of collectors to the Streams API that will let you create instances of these new collections. So one thing I'll mention is so notice if you recall earlier I said that set.of will throw an exception if it encounters duplicate elements, because the presumption is if you are writing these out by hand and they're duplicates, then you made a mistake. So that's why we throw an exception. In these cases, since these are computed from somewhere else, you might take a list and then copy it into a set. And in that case, what we do is we will compress out the duplicates. So duplicates are allowed in this case because this is different from the collection literal style of programming. So for these methods, it is not considered a programming error if they're duplicates. So that's something that people really missed with the existing ones, because what they wanted to do was compute some elements and they'd copy into an array. But if that had duplicates, then they'd have to deduplicate it and then copy that into a different array and then load it into a map or set using the array factory methods. And so that was very cumbersome. So instead, these will compress out duplicates. All right, so that's about it here. I think the main theme of this is that when I started off, I talked about the history of the collections framework being almost 20 years old. I think it's still important, useful, and very relevant, and it's in daily use, and very popular as far as I know. And so even after all these years, we are still enhancing it, and so it's useful and extensible, and we're continuing to work on it. So as you know, JDK 9 shipped this year. Actually, I'm sorry, I'm not sure one of these URLs might be wrong, but I think that I think Java 9 is generally available, so it should be easy to find. I encourage you to download it and try it. We have started to ship JDK 10 builds at this point. The new proposed factory methods I talked about a bit earlier are not yet in the main line, but I hope to get them in over the next few weeks. And so you should be able to get a JDK 10 build and try those out as well. So I'm Stuart Marks on Twitter, and then if you look at the top, there's the collections refueled hashtag, and so you can tweet on that and I'll look at it. And we actually have a few minutes for questions, so why don't we open it up now? All right, we got one question right there.
Yes. Why do you have a single implementation, single function implementation, and not use the builder pattern?
Okay, the question is why single function implementation and not use builder? Well, so it's not entirely clear what the value of builder would add. A builder has a very high API surface, and so for most of the implementations, or for most of the cases, we felt that simply having the overloaded methods was satisfactory. We did consider using builder for the map.of entries, but what I need to do is write an article about all the different things we tried for map.of entries. I think we analyzed 14 different proposals for that. And we did include builders in that. I think what it boiled down to was if you used a builder in that case for map.of entries, it was basically the same as building up your own hash map and then copying the elements into an array. So we did look at builders, and they just didn't seem to be helpful. Any other questions? Yes, right here.
Is there an API for the immutable collection to say your collection is immutable?
Okay, so I'll rephrase your question. I think you're asking, is there a different interface in the collections framework that designates that the collection is immutable or unmodifiable? And the answer is no. We're thinking about that a lot, but it's actually, there are some subtle and difficult trade-offs about that. So one is, so the kind of the obvious thing to do is to say, so suppose I say list.of ABC. What that does is it returns a list. Shouldn't it return a new type named unmodifiable list? Well, okay, sure, yeah, that's kind of a reasonable thing to do. So think about where that would go in the collections hierarchy. So the list interface contains things like get, and it also contains things like add. So if you have an unmodifiable list, you might think, okay, so that should be a super type of list because you don't want it to have the add methods. The guy's shaking his head because he knows where this is going, right? So if you have an unmodifiable list that's a super type of list, that means every list is an unmodifiable list. Okay, that's wrong. Okay, so maybe you should have an unmodifiable list as a subtype of list. Okay, what do you do with the add method? Okay, so now what you need to do is enforce somehow that the add method always throws unsupported operation exception. You can't do that in an interface. You could do it, and this is what Guava does. They have an abstract class called immutable list and set and map, so that's a public class, but it has no public constructors. And so what they do is they have their private implementations of add and remove and so forth do throw unsupported operation exception. But here we have this, so there's a smell here in the API already, which is refused bequest, which is you are a subtype of something, but you are explicitly disallowing certain operations. Okay, so that's one thing, and we don't know how to deal with that. But then the other thing is, I think Guava did something that was useful and helpful for them, which is they have complete control over their own immutable collections, and those are all inside a single package. So their framework is not extensible outside of Guava, and so for Guava, that's just fine. We considered doing that, but we didn't want to commit to that being the long-term evolution path of collections, and so we've held off from doing that. The fact is that in the original collections framework in 1.2, there are already these things called collections.unmodifiable list and so forth, which return the same old list interface that that throws unsupported operation exception. So we're kind of continuing with that. We've looked at alternatives, like I just outlined, and those are not necessarily any better. So we're continuing to look at alternatives, but I think that it's one of those things where the obvious thing of just add types for unmodifiable or immutable collections, it's not so obvious after all. So it's something we've investigated and we're continuing to think about. All right, I think I have time for one more question. All right, this gentleman right up here.
Is there any chance that the decision for the random iteration order could change to insertion order, or is this settled?
Okay, is there any chance that the randomized iteration order could change to insertion order? Well, no, since the system is already shipping, then no, it's out there and it does what it does. But people have asked for an unmodifiable insertion ordered set. And there's an RFE for that, and I think that if that's something that people are interested in, we could add that in the future. But that would be using a different API. So instead of set.of, it would be set.of_ordered or something like that, or maybe that would be a better word would be chosen. But basically, then you would list the elements, and then those would be iterated in the, it wouldn't be insertion order per se, but it would be like in declaration order. And so that's something that people do find useful, is to have a predictable ordered unmodifiable set. And we don't have that, but that is something we're thinking about. All right, my time is up. Thanks for your time and attention. Enjoy the rest of the conference.